I guess I'll begin now. We got the technical issues solved 1 minute before the talk. My name, there was some confusion on the talk titles. So there was one where it was key trends in graph visualization, and in another place it was the future of data visualization. So I thought that one sounded better, so I renamed my slide. My name is Brendan Madden, and I'm the CEO of Tom Sawyer Software. I'm going to speak about the big data problem in general and how we are working to solve some of these problems, and how we work with Neo4j in more detail. Can everybody hear me? Okay. And so I'm going to just do some PowerPoint, and then I'm going to do live demonstrations, and then I'll try to have a question and answer session so who is Tom Sawyer Software? I think we're the leading provider of software. We help customers build graph and data visualization applications, and our flagship product is Tom Sawyer Perspectives. In the last 4 or 5 years, we've grown into a more full-service data visualization vendor, and but we're working 25 years on graph visualization, graph layout, graph analysis problems, and a lot of problems in graphics and presentation clients and the like. Our headquarters is in Berkeley, California, and we're largely a distributed company now. We're in Newcastle, Australia, Germany. We have a new presence in Greece, Riga, Latvia, and Mexico City. And then we have people sprinkled around in different places. We worked many years just in graph visualization problems, automatic layout technology problems. But as we've been pulled into various public sector and enterprise clients, we've started to do more work with time-based data. So we're doing more work with data in general, but we're also doing work with location-based data, time-based data, and relationships in data, and also working with federated multiple data silos that organizations, all the large organizations have lots of silos of data, or they have lots of people with Excel data, lots of SQL and RDF data, and most of them are doing, they're either are building new applications flat out in Neo, or they're modifying, they have systems of record that are running the company or running large parts of the company, and they're piloting new projects in graph databases. So Neo is the clear leader in that, I would say, in the graph database space, but it's also, I think, the most important trend in data, I think, at the moment. So we're seeing a lot of silos of information, and then the question is how you bring that data together and work with it. So we make we're a platform maker or a general technology vendor, but we have a strong presence in network topology. So telecom providers, service management providers, video, people processing video feeds and other things. So there's a whole equipment space, telecom space. Then there's link analysis is working with attributed data, relationships, people, places, and things like public sector problems, intelligence problems, police problems, fraud detection problems. So this whole area, we kind of broadly classify it as link analysis. That's what we call it. And then we have a lot of work in schematics and maps, utility data, electrical circuit data, outage data, map data, and then in more recent times we're seeing a lot of architectures and system modeling problems. So you see enterprise architecture problems, data models, system modeling. So it's a whole, risk models, all sorts of data models. And then we also have a lot of experience in transaction data, flow data, process data, so dependencies and information. So each of these we have kind of a skill base in building applications. And these are just a few of our clients. You can see in networking we have like Riverbed, Cisco, IBM Tivoli, CA. Aerospace, we have JPL, Lockheed, Northrop Grumman, NASA, and then you see Airbus as well. And then you see retail like Bloomingdale's, Macy's, and then utilities is like GE and Nexent and some other vendors. Since this is New York, financial sector, we have some central banks and some like Bank of Portugal and Deutsche Bundesbank and some others. And BP is also a financial application, even though. So that's just, there's a lot more customers, but that's just some sample. We worked 25 years, and we started licensing to software companies. So we built software, graph visualization for software companies. So we had many SDKs in the early years. We had a classic customer was a software company OEM who built. They had a year back then to put us into a new version of their software, so we made many SDKs, programming toolkits. But we wanted to be able to move beyond selling only to software vendors and reaching to work with systems integration firms, to do piloting POCs, large projects ourselves directly with like corporate, American companies or European companies and the like. So we started to move up out of the level of like core programming toolkits, and we started to move to a design-oriented model. So we actually have a design, preview, deploy kind of tooling architecture that's different from having to like jump into code first minute. And so the idea is you design an application, but you can do a late decision of where you're going to deploy it. So like a single application design, you can decide you want a .NET application or a Java, Linux, web application, or you could say the same application I want to deploy to desktop or web. And so we have HTML5 technology in the web or image map technology for rendering. And I'll show that. The way we do that is we have something like an IDE, which you use to design applications, and there's some concepts. We do everything now from a data-oriented point of view, so people are working with their entity types, or networks would be device, switch, router, bridge, service, or medical might be gene, protein, whatever, in healthcare. So you're working from the data model of the application, not just from nodes and edges, or nodes and links, or shapes and routes. So the idea of use this design tool to define or load your schema, like what's your data about, what's the restrictions on your data, like a person might have date of birth or social security number, address, whatever. So that we call the concept of integrator is how we bind to data. So we have a federated update and commit architecture. So we can define bindings to numerous data sources, and we can also write back to those data sources in a federated way. So it's like federated update, federated write. And views are, the idea of a view is, we had a problem was we want to be able to have multiple simultaneous synchronized views of information. And so we needed our own data model, and we needed a way to be able to say, well, here's our model and here are our views. So we have a way to, you write rules and expressions and stuff. So you don't have to code to actually define the graphics. So you could say this data property goes from 0 to 1. Okay, make the color go from red to blue. So you write rules to express what you want to see in the graphics. And you do that for all the different view types that we have. So that's what we call view definitions. And then we have filter definitions. It's all done in the design tool. And then you have search definitions, like I would like to search for all the routers in the network, or search for a router named San Francisco. So you can do it on the type level or by the instance level, by So the idea is you define an application, and when you save it, it's an XML definition of how you go all the way from your data to your graphics and all the interactions. So, and you can do all that without writing any code, and then but it's still an SDK, and you customize. So it's still a large SDK, the whole product, and so the solutions of our apps, what I mean is, the views we give people can be embedded in the, in our customers' applications against their data. So we're not so I'll just keep going. So in the data integration sense, Neo is our most important source of new activity, I would say, and they're really helping. So we were among the first graph technology companies, or we were the first, I believe, in the United States in the early 90s, the pure graph technology company, but we didn't have a graph database back then. So before the graph databases came along, we were working with SQL and text files and XML files, and and in more recent times, JSON data or RESTful service data or web service data or Excel data, and then also Tinkerpop and other graph database sources. And the other one is really customer data models. They can write Java code, or they can populate our data model from their data model. So that's like a model-to-model thing. And but what we can do is bind to multiple sources, including Neo, and then integrate it all into a single model, a single attributed data model, and then write applications against that data. So, in more recent times, we do a lot of work with Cypher, and we have Neo 4J Bolt integration. So we've started to go. So because we worked before the graph databases, we went from graph data. Well, we went from customer data to table data models in memory, and then back to graph-based views of data. Now we're going from graph to our own graph data model to our own graph-based views. So we're able to extract the property graph. We're able to do a schema extraction and populate some subset of the graph database into our own graph-based data model, and then so we can do Cypher queries or just one-to-one extraction, and the idea is. We're able to quickly pull in Neo data, and we use the Bolt protocol as well. So it's a binary transfer protocol, and so it's about 15% faster than before Bolt. That's what we discovered, and it's more secure and it's encrypted. So it's a nice that was a nice change recently. So what kind of views of data do people have, and what do they want? So we were many years just in graph-based views of data. So flow data, web-based data, model-based data, nested drawings, routing, labeling, drill down, all this kind of stuff. So drawings is our deep area, and in the last few years we work on some federal projects. We started to do timeline integration, so you can work with time-based data. We integrated charting architecture. We've built our own something called Tom Sawyer Maps. So we have a Google Maps integration, but we also built open layers, OpenStreetMap integration. So we actually we use the same rendering technology, and we inject maps into our rendering client. So we actually can use the same toolbar system, context menu system, graphics system as our drawings use, but we inject maps into the nodes and links, and so I'll explain that. And then we have table-based views, sort of like spreadsheet table views, tree views of data, and then sort of VB-style inspector views, like if you click on a node, what are its properties in an inspector. So we don't just do like one Spring embedder or one network view. We do work with an automotive, electrical schematics, automotive diagrams, like hard things. So we have constraint-based automatic drawing. You could say like these nodes are above these nodes or above these nodes, or you want swim lane process drawings. So I'll show how that works. We have advanced what we call incremental layout software. It's like mental map preservation as you make changes to the drawing. The drawings update. So nesting, jump overs, level of detail. I'll go quicker. And a lot of work in labeling technology if you want to label the links, label the connectors on the borders of nodes, or label the nodes themselves. And we also have in 2002, we made our first product in analysis. We called it, well, it was first called Graph Analysis Toolkit, and then we rebranded everything Tom Sawyer Analysis. But it has about 30 algorithms now, so we put it into six classes. Groups, which is like partitioning and clustering algorithms. Social network analysis is like finding the middlemen in networks. What are the that's like to find the middleman or to find the source. How a leak would spread through an organization. That's different kinds of centrality. Social network. A lot of pathfinding. So shortest paths. All pair shortest paths, give me the 5 shortest paths, like Google would do, give me the 2 or 3 routes, so you could say from shortest to longest, these kinds of things. Traversals is like scheduling. This has to fire before this in a dependency graph. So, and then reachability is neighborhoods. You're working, what's within 5, what's near me in a network? And then network flow algorithms. That's a different area. That's very academic. But so that's all for PowerPoint. And let me get out of here and show. So is the pace okay? Okay. Okay, so this is so if you see, this is our Tom Sawyer Perspectives design environment, and you can see we have examples for like many sectors. So like banking, big data, business process, or utilities examples, or you can see there's a lot of example applications basically. So I'll just start with a simple one. Just to give you a feeling for what the software does. So this is just a simple, you can see there's just, the data here is coming from 2 Excel sheets, just a simple example. You can see there's, the appearance of a node device. So we have our own level of detail graphics system. So you have a scene graph per node. So you can do all sorts of rule-based control of the node graphics without code. So and then you can see this application has all these views of data. So it'll have 3 drawing views, 2 trees, 2 tables, and an inspector, and then you see some filters. So this is a pre-made application design because I don't have time. And you can see here's a desktop view. You can see, I didn't think it would maximize, but sorry. So you can see just a little bit simply, that's like what we call symmetric layout. This is what we call like orthogonal drawing. You can see, lots of tools. So if you look at the nodes, you'll see the rendering changes as you zoom. Yeah. So that's like what we. A zoom-based level of detail graphic system. So it's all, and the clipping to the nodes is all dynamic. If they change size, change shape. And sorry, it's a little bit, or if I wanted to search for something like router, you can see, so an integrated, so you see synchronized rendering, you see the table view update, the tree. So you can see in this tree view here, you have location data. So that router A is in site 1, but you can also see, it's also a router. So it's all the views of data are synchronized and highlighted. So no matter what, or if I click over here, everything syncs together. So that's a simple example of synchronizing information, and that's just that's desktop technology. So I'll close that, and then I'll just do the same thing deployed to the web. It's going to take a couple seconds to initialize the JavaScript stuff. Give it a. Yeah, there we go. Okay. Okay, there you go. So you'll see this, now you see the same thing in the web. In HTML5, you see things like overview windows like this. You know, you can navigate, same search, you know. So you see the same app just deployed 2 different places. And then I'll show something like grouping the info. So you see data-driven graphics, you see. So now I'm grouping the information by site. So, and then you see integrated nested automatic drawing. So, and you see the nodes are blinking. So we're using status data to drive an attribute on the node to blink. So it's just, so you know, this is just a simple example. And then you can see there's all sorts of filtering. So if I want to turn off, like, you know, you see it's all data-driven, you know, so you see it's data-driven graphics as you work, you know, so you can make those tree controls act like filters, and they can all be data-driven based on the values that are in the attributes. So that's a simple network, and this is also an editing example. So you could, you know, you could edit information, for instance, and, you know, turn off the grouping, you know. So you see it's you know, and then you see something like an incremental layout if I want to clean that up. So you see it's like a smooth update to a drawing where all the relative positions are preserved. So that's and then you see things like I could undo that if I wanted in the web, you see, or redo it. So you see undo, redo with a server-side command stack, and you can send the changes to the browser. Okay, so I'd like to show a more complicated example. Okay. So this is, yeah, I don't know why the thing keeps doing that. So I'll show a governance example. It's sort of like entity data, so directors and officers of who are associated with organizations. So I'm going to open a project and do a web deploy, HTML5 web deploy. So this is like a symmetric view. You can see over here the statistics: 40 companies, 570 people, and 744 relations. So this is a what we call a symmetric view. This is another view we call, we also have like orthogonal drawing views, overlap-free orthogonal drawings of, so you see, what you see about this kind of a drawing is that no matter where I zoom in, let me see if I can find a nice place. Every label is overlap-free. So you're not seeing all the labels crossing. They don't lie on crossing points. You see clipping, precise clipping to the graphics. You see jump overs. You see, you know, the labels are all readable, which is very, very hard problems. And so this is you see here there's companies and people. So you see people associated with companies. But you might say, well, what I'm really interested in is the social network. I want to know who may know who, because maybe I need to understand. So we use our rule-based system to infer graphs as well. So the database doesn't have a social network here. It just has companies and people. And we can go and then say, okay, well, let's look at the social network of that. And yeah, so the social network has, we use a simple rule. If 2 people are associated with the same company and they're directors and officers, they probably know each other. So a simple rule, we make links between those people, and that's, for example, their social network. And so then you might say, well, how would I do something with this data? So you might say, well, let's go back. I just want to show something here. So maybe I need to figure out how to fundraise in this network, or I need to find out who's a key influencer in this network, who's the most important or high priority people in the network. How would I work with? How would I find them? So we might say, well, let's do a degree-based filter. Say, well, let's look at parts of the network that have more than one connection. So I'll filter everybody out who's degree 1. If they only have one connection, I'll filter them out. So I'll say, okay, like degree 2. So that's actually a data-driven filter, and then I'll clean that drawing up. And you see something like the way the incremental drawing works again, and you can see, if I zoom in anywhere, like I was saying, you can actually study this and actually follow it around and read the drawing. And so now you see if I go to the social network, information has been filtered out. We'll clean that up now. And then you might say, well, let's do some social network analysis on that. So we have various algorithms here on the toolbar. Let's run a betweenness centrality. So what this does is, like betweenness is a measure that says score individual nodes based on the sum of all paths that flow through them. So it does like an all pair shortest paths and sums if the paths flow through those individual nodes. And so I ran this, and then we have a rule that we take the score and apply it to the node size, data-driven resizing of the node. And then you see we populate a table over here, and we can focus in and find those people. And if I maybe that you see that's and then I relay it out, and I see okay, here's this guy Marshall. Maybe I want to go back over here and find out, what companies this person is associated with. So you see the synchronization helps me go back and forth. But anyway, you can see that this information, very quickly I've said, well, if I had to fundraise or network with these people, maybe I'd target the top 3 or 4, and that's how I would start, just as a simple analysis, right? So I'll just jump to the next. So yeah, we're tying a bunch of things like graphics, synchronization, filtering, multiple views, tying it all together to try to do something useful. I'll show a more, a larger example. I'm running out of time, okay. So just, I don't know why it keeps doing that. So I'll just show one more. This is sort of similar, but it kind of builds much further on it. So this was built by an entry-level new employee in about a week and a half the first time before we then debugged it for a long. But this one young engineer built most of these views and did it in about a week and a half. Where that would. It cuts 70 or 80% of the work away that you would have to do if you coded everything, maybe more. So so this is actually police data from Seattle, and we've augmented it with some relationships because it was a lot of incident data, which means like who was arrested at this place, who was in the car, this kind of problem. But I'll show. This combines more of our technology, so so here again you see the people and incident network, you see a people network, and then you see this is the Seattle data over here. So, and I have all sorts of filters. So and then we've augmented it with, so here you see the time those events occurred over a 2-year period, and we can filter and play. Like the timeline, we can play it through time, like watch it evolve, or we can filter on a time section. And so here we have time-based views. We have so you can see what kind of the data, what kind of incident data it is. So you see, a lot of burglaries and car prowls and property damage, for example. And then we have like a metadata viewer here. So if I was looking at the assault type, I can see a breakdown of what kind of assaults, or if I was looking at, so all these are data-driven, populated, all populated dynamically, and you don't have to hand code everything. So for instance, if I was just looking at narcotics data, So this is kind of a simple metadata viewer, and you can see classification. So I can see, what kind of narcotics, or I can look at people by their age in the data. I can look at the precinct data. So just to show you the filtering, if I come back over here and said, well, I don't want to care about this West precinct anymore, and maybe I won't care about the Southwest precinct. So you see it's all data, it's in a data-driven manner, it's changing the drawing views. So I can, for instance, clean that up, and you see we also have a lot of packing technology to fill the canvas with matching the aspect ratio of the drawing, of the canvas, for instance. And, same here, oops. Or do something like this, Yeah, so you see it's kind of still a complicated network, but you might say, and then you can see the data on the maps now, and if I were to so this is now our rendering client here, like you saw before, same toolbars and everything, except we're injecting OpenStreetMap data in, and we have like clustering, we're doing clustering, and now, as at a certain zoom level, we turn the clusters into the original incidents. So, I could, I can click on, I have to see if I have time, but yeah, if I click in there, yeah, I see the detail, and then if I come over here, okay, this incident, okay, there it is, so, and then I also see, it's in the North Precinct J. It's a property incident as well. So I'm able to kind of infer quickly. So this, anyway, this is, I could keep going, but I want to move to something another more interesting one. So if you ever want to go to our website, we have all these solutions demos live without having to, you could sign in and just run them yourself. But if I was to say, in the processes one, this is like it didn't save my password for whatever reason. So this is a Neo4j application where it's some government data about financial flows across the states, like and all sorts of data, like manufacturing data, just commodities flowing through the country. And so I like cars, so I just like to show, I'm interested in cars. So for example, I might say, well, let's see what's going on in Michigan, for example, Ohio and Texas, because I know a lot of trucks are made in Texas and Ohio, and then maybe I'm interested in so there's basically a first query that finds out the commodities that are in the database. That's a cipher query to just extract the commodities, and then we built a data-driven view to just give people a checkbox, instead of having to write queries. We just gave them an interface to the queries, and so this is all. So I'll just do something like this and query the data. So here's like a chart view of like the imports and exports of particular regions, and here's the map. Here's a map view of like how the commodities are moving on the map. And for instance, here's a large flow graph of the where the commodities go and how they move through the network. So that's fully automated. There's nothing pulled from the database. It's loaded, calculated, full real time. So and you see, so there's rotate. It's like that's not the clearest, but the rotated labels along the links and stuff. So and then you see, you can see, you can format tables or whatever you want to decide what attributes you want to show, sort them or whatever. It's kind of nice to, just to try to get something quick out of it. So if I might just say, well, let's group by state now. and I do a data-driven, and so I see the 3 states. Here they are, and I kind of see where the stuff is exported from and where it's imported to. So I can quickly, I forget which. That's Ohio. Yeah, tooltip says Ohio. Then we have Michigan, and so Texas is importing more than the others are producing more. Texas is importing more. I think, and so I could look at that like with another drawing view. So this is like an automated orthogonal drawing. So you see like a nested, a fully nested drawing of that information by state. And then you might just say, well, let's collapse it down, into one, and you get something like this. And so here we roll up the flows into the summary links, and you can kind of quickly, and then maybe you want to go back over here, and just play with the imports and imports and exports of pairs of states or something. So let's look at Ohio and Texas at one time, and so you can see how, so you're very quickly learning about this data where it would be extremely difficult to look at massive spreadsheets, or it'd be impossible basically. So, but you're seeing information rolled up and useful to users very quickly. So yeah, I'll turn Michigan back on, and now I'm looking at Michigan and Texas flows, or I'm looking now, or let's look at Ohio, Texas flows, for example. So that's just a, simple, so that could be used for transactions, or, looking at, financial flows around the world or whatever. Well, I'm running out of time. I'm sorry. Would anybody have any questions? I could keep talking, but oh yeah. Oh no, it's a full it's a full editing and commit environment as well. Yeah, so we have actually if you integrate data, so it builds like a two-way binding from the sources, and then like you can write back to SQL or Excel or to Neo, and it works. Yeah. Yeah, so it can actually, it knows how to write back to multiple sources, as far as I understand. Yeah. Oh yeah. Oh, sorry. Oh, how do I define them? Yeah. So here, so in our design technology, you can see. So for this one is just like a simple Excel, right? And so you can see here's the full path to that data file, and I can specify a URL or file, and I can test the data source, and I can set the locale of the data. But then you can see I've got bindings to the data, and so it's like point and click bindings. So this is you can see, so we actually extract from multiple sheets in Excel into a design interface here. So you can see like, okay, incident data. So you see how someone pointed and clicked to bind our attribute name to the location in the Excel. And it sort of works similar for XML data or SQL tables and I'm not as good, I'm not as good as like how to do it, to bind to text or to Neo. But you can see here if you, you can see how we have lots of integrator types, that we and basically it federates. It'll so we can bind to all that types, all those different types of information. Yeah.